Hello, hey everybody. Today we're going to be resting easy with Jupyrest. I tried to find, so I know a lot of cool open source projects have like a mascot or a logo, so I used some AI to come up with what a logo would be. So I'm calling him Jupy and he's asleep, so he's resting. All right, and who here's used a Jupyter notebook before? Yeah, okay, great. We love notebooks. So a bit about me. I am an engineer at Microsoft. I work on the Azure Cosmos DB database. It's a distributed NoSQL database, and it's a lot of C++. So on the side, nights and weekends, I call myself a code artisan, where I explore in more fun things like Python. And that's what I'm here to talk to you about. There's no databases today. So before I get into what this whole thing is, I want to talk about this concept of serverless. So if you don't know, serverless is this new way of deploying your code and making it available to everyone. You have products like Azure Functions, AWS Lambda, etc. And what it is really is nowadays, if you just want to deploy your code as a web service, you can take your main.py, your Flask app, fast API, and literally upload it somewhere, and someone will take that and make it a web service all over the world, and you don't have to worry about how much memory your server needs or what the CPU is. None of that stuff. It's so-called serverless, and it's been a pretty popular paradigm for deploying web applications. These people, they handle the scaling, authentication, monitoring, and a whole lot of other really annoying things. So the problem is that I like to write code in Jupyter notebooks, especially Python code. To me, it's the superior development experience. I mean, it's the only place where you can actually interleave code with documentation and have interactive widgets, tables, charts. It's just as approachable for a beginner as it is to an experienced developer, so it really is a wonderful way to write code, share code, and visualize what you're doing. I think it's amazing. But there's no way to take a notebook and really productionize it. I mean, once you've written a notebook, it kind of stays in that prototype, POC kind of mode. And if you really wanted to turn it into a product or turn it into a website, you'd have to rewrite it. You'd have to strip away all the goodness that is the notebook. So that's where I came up with this thing called Jupyrest. It's a tool to turn your Jupyter notebooks into REST APIs, hence the REST. So I like to call these Jupyter notebooks as notebook functions. What the library will do is it'll let you define some inputs and outputs for your Jupyter notebooks. This library I developed working at Microsoft starting around early 2020, and now it's used extensively by pretty much all of Azure for various different things. And I've built it in a way that you can deploy it as your fast API or Azure Functions, or really however you want. Even just running it on your own laptop works as well. So there's no like lock-in or any proprietary stuff. About a year and a half ago, I got the approval to open source this under MIT license. So now anyone can use it, which is why I'm able to talk to you about it today. So what is a notebook function? So notebook functions, basically like any other function, it's got an ID, an input schema, and an output schema, just like any web endpoint. So I'm going to show you how you take a very basic notebook here and turn it into a notebook function. So I've got a hello world notebook. It doesn't do very much. You have your name world here, which is basically like your input, and then you have an output here. And you can see here in the that last code cell, we're importing the save output function from Jupyrest. And whatever you put into that save output function becomes your notebook's output, or it's like return type. Imagine you're writing a normal function. So now that we have our input and output marked in our notebook, the next thing we need to do is to define the input and output schemas. So in order to do that, you need to go write this config.json file alongside your notebook. Basically, it just needs to have the same name. That's how the library knows what it is. The first part of this file is the ID, the name of your notebook function. The next part is the input schema. If anyone's used Swagger or OpenAPI, this should be familiar to you. It's the JSON schema here. So it's basically saying this function takes an object where the name is a string and it's required. And same thing for the output. We also have a JSON schema spec here. So you include all these things, and now you've successfully turned your notebook into a notebook function. So in order to start the Jupyrest server, I've added a little code snippet here. But rather than go and explain all this stuff, let's go do some demos. Okay. So I have this notebook here because, of course, I'll do a demo in a notebook. It's all of this is on the GitHub page, by the way, the full example project. So I'm just literally taking and running this as is. This piece of code here is just some helper functions for this presentation. But essentially, what we're doing is we're instantiating our Jupyrest client. That Hello World notebook I was showing before is right here. And so we're just going to demo how we can invoke our notebook function. So this client, it lets us get a list of all our available notebook functions. It also lets us get the details about any notebook function. Like right here, we've got the Hello World notebook and the input and output schema. Now let's try and execute this notebook here. So what I'm doing intentionally is providing a set of parameters that is invalid. Remember, we needed a name, and here I'm passing a foo. So as you'd expect, we're getting a error here. And let's fix this. What's that? Okay. Okay, now let's actually execute this notebook with the proper schema. And so what this is doing, the library, it's taking our notebook, it's adding our input parameters to the notebook, and then it's running the notebook from top to bottom. And when that happens, we're going to get our output here. Hopefully this runs a little bit faster. I think it's running. This is the fun part about demos. I think it finished actually. Okay. Anyways, it finished. So here we can see we've got our JSON here of our completed execution, and I have this little helper thing here for us to visualize. So the first thing we get when we execute any notebook is that JSON that I just showed you, pretty standard. The next thing we get is the full HTML output of the notebook. So you can see here, the parameters that I passed into that execute notebook function, they've been added as a code cell into my notebook and then run from top to bottom. So now my inputs have now shown up, my notebook's running with the inputs that I configured. The next thing we get that I'll show you here is the output. And so what this is actually whatever we pass into that save output command, we get that back as JSON. So I passed in, hello PyTexas in the save output command, and so now I'm able to get that as a JSON output. So I've effectively converted my Jupyter notebook into a REST API. So it's got the JSON in, JSON out, but in addition, I also get the I also get the full notebook HTML as well. It's an extra benefit of the notebook. So any charts, graphs, even documentation I can put in here, I get that as well. So you get both the input-output as well as the notebook itself. So these are some of the artifacts I just mentioned. The other two here. So this is the HTML report, which is just with the same thing as the HTML, but it has all the code cells removed. So this you could. It's kind of like a report if someone doesn't need to look at the code. So the output here I already showed you, but you can basically get that output JSON from your notebook. So now the next notebook I'm going to execute here is a notebook that I've purposely put in an error. So as we know, when you deploy or write any code, you're going to have exceptions. So I have a notebook here that is going to fail. We say that it's failed. Now, normally when you debug a web service and there's some error happens on the server, you have to go scroll through your logs, look up some telemetry, try to find out what happened, and then try to reproduce it on your laptop and then make a fix. With this, it's way easier. So now I've executed this notebook and it's failed. First thing, I get the HTML. So I don't need to go look at any telemetry. I can just look at what happened in the notebook. Secondly, I get the actual IPyNB. So this is, your notebook JSON file. If I want to reproduce this error, I can download this file, open it up in Jupyter Lab, and try running it on my computer. I don't need to do anything more than that. It's very easy to reproduce. So even just by using the notebook as the function unit, we get all the benefits of the notebook. Like debugging in a notebook is way easier than debugging using like Datadog or some like log system, like looking for all the red text and try to figure out what the heck happened. So with this ease of use and ease of debugging and ease of authoring has made this library very popular within Microsoft. We've enabled lots of data scientists and people who normally don't know how to write production code. We've enabled them to now share their logic as notebooks to the rest of the company, which has been great. And it's really made the notebook so much more powerful. So what happens is when you have, let's say, hundreds of notebooks that you've deployed, what you end up wanting is to put some structure to your API. So what I'm going to go over here is a little bit advanced, but when you see how cool it is, I think you'll appreciate, just how awesome this feature is. So we have this ability to share input and output models across your notebooks. So what I've done for this example, I've taken a notebook straight out of a GitHub repository here. It does some portfolio analysis. And I want this notebook not to take in just JSON, but I actually want it to take in a Python object as input. So I've defined a Python object here called portfolio. It has a start date, end date, and some holdings. And in my portfolio analysis.config.json, what I'm going to do is I'm actually going to reference this portfolio object here. So basically what this is I've given it a name here in the application builder, and in my portfolio analysis config.json, I'm referencing the name of that model. Okay, so what does that mean? So when I get this notebook schema, you can see here the input schema is actually getting resolved to a still standard JSON schema. So it's your definitions, and the portfolio object here this is all very standard JSON schema, okay? So from the client, it has no idea that this input is a Python object, okay? So now let's go and execute this. So I'm executing this notebook. I'm passing in straight JSON, and this JSON is adhering to the schema of my Python object. And what will happen is, we're going to be parameterizing this notebook with the Python object that I just provided here. So let's take a look. When I open this up, you can see this is these are the input parameters I just passed into the notebook, but they've actually been converted into Python code. So this notebook does not need to know it's actually being used as a web API. All it knows is Python. So it's Python in, Python out. So, but from the client side, the client is sending JSON. Like, this is not a Python, this is just JSON. So what Jupyrest is doing is it's smart enough to say, okay, you're passing in this portfolio object. I'm going to convert it into this Python object that you want me to, and then in your notebook, I'll make it so that when you run it, you're getting your Python object as is. There's no JSON serialization or any of that stuff, which is great. So this notebook, it's a little bit more involved. It has a bunch of stock stuff here. Honestly, I don't actually know what any of this means, but there's some nice graphs. And you see here, I'm also saving some output. So just like the other notebooks, I'm able to get a JSON output as well. So if all you want is to just look at some condensed information from your notebook function, you get that. But if you want to see the details of how the sausage was made, you can actually go and see exactly how the notebook arrived to that final result. So it gives you a superior introspection to your web APIs. It also lets you write your web APIs in a much more Pythonic way. I'm just dealing with Python objects here. And it lets you hold on to all the amazingness of the Jupyter Notebook while still being able to deploy your code as a web API. So that's pretty much all I had for the demo here. I will say, just for context, while this is a very popular library, it definitely has, it is good for certain things and not good for certain things. So you definitely wouldn't want to use this for any performance critical service. Like if you really need like 10 millisecond response times, this is not the thing to use. But if you're trying to build something and share some analysis or share some notebook with other people where you're okay waiting maybe like 10 to 20 seconds for each of these notebooks to execute, it could be a great way to take any of your work and share it with other people. So it's a great tool for prototyping. It's a great tool for automated reporting. And I think it just makes writing in Jupyter notebooks, even that more powerful. So that's all I had for you today. Feel free to check us out on GitHub, give us a star, and find me on LinkedIn if you want to hit me up after. That's I guess the social media I use. So thanks everyone.
Awesome, thank you. We have a bunch of questions. People are excited. This is good.
Right.
So let's run through some of these. The first question opens, very cool.
Thanks.
Which is not the question, but had to pass that along. Okay, now the actual question. How's the tooling around diffs for code reviews of notebooks? Also, how do you test notebooks?
Great question. So let me show you in our GitHub. So diffing notebooks is always that's always a pain, right? Because they're just JSON. So in the example project that I have here, I've actually included this pre-commit hook. And what this pre-commit hook does is that anytime you commit a notebook, it commits it generates a Python file, of your notebook. So all the Python code is also alongside your notebook. So anytime you're doing a code review, you'll of course get the diffs for your IPyNB, but really the more readable diffs will be for this Python file here. So that's how I've gotten around that problem. I know there are other tools for that, but just for myself and at Microsoft, this is how we solve that problem. The other thing is testing notebooks. So that's a good question. I know you could do two ways. One way is you could still use PyTest. Any individual modules or libraries you use in your notebook. Of course, you can test those with unit tests in PyTest. The other way is actually in the Jupyrest source. I do have a way to do integration tests. So in our this conf teft here, I have a thing that just starts up the local HTTP server, and then I can use that same client to execute the notebooks and test them.
All right. Sorry. So the next question. See, Josh keeps moving them on me right as I go to answer them. How does Jupyrest deal with interactive components like a Plotly graph or Jupyter widgets?
Yeah, that's a good question. So for Plotly graphs, you'll have to make sure to, I think a lot of those, like as long as all the data is saved in the notebook, then the interactivity can work. The problem is that, this HTML file that you get, of course, there's no running Jupyter kernel in the back. So if you're going to click something and it's expecting to call some Python function in the kernel, that won't work. So if it's something that's static or something like, I know Plotly charts, you can, as long as all the data is in the notebook, then you can filter it and zoom in and out. So you are limited to that, but yeah, that would be how that would work.
Okay. There went. I like this one. What original problem were you working on when this idea came to you?
Yeah, good question. So the problem I was working on, so I'm a site reliability engineer, and as a SRE, we have a lot of these runbooks that we have to follow whenever a certain incident comes about. And you go anywhere, and most companies will have a set of these runbooks, usually are markdown documents or whatever, Word documents, something like that. And you just have to follow these step by step to resolve an incident. The issue I found was that a lot of times I'm going there and copying, pasting code snippets, changing a few things about the timestamps, and then running them. So I thought, okay, why don't we just make this into a Jupyter notebook? And then I thought even more like, okay, if I'm already going to be writing this as an executable Jupyter notebook, let me slap some parameters on there. And then basically what I did is I built this, and then I hooked it up to our internal incident system. So anytime an incident was raised, one of these Jupyter notebooks would be executed with the parameters of the incident. So then if I was on call, by the time I get out of bed and go to my laptop, a bunch of these runbooks are already executed for me. So I don't need to go do any of that. So I can just open them up and see this is the problem, or maybe a graph of some CPU history or whatever. It'll just tell me what I need to do. And it makes it so much easier for onboarding, because now I don't need to, I can now test my runbooks. I can now make sure that they work in our staging environment, our dev environment. So that was the original problem, but then a lot of other people started using it for various other things, but that was the original intent behind this.
Okay. That is cool. I do have a few more questions. You want to unplug while they're setting up?
Yep.
But I do have more questions for you while they're setting up.
Sure.
Because we're getting some really good questions in. Thank y'all. Y'all are being creative. I don't know if it's the after lunch, the sugar, but y'all are helping. This is awesome. Since you open source this, are there any uses that have surprised or delighted you?
I don't. I think there's a lot of people who are using it to automate whatever AI stuff that they want to do. So of course, notebooks, you can, because they're in Python, you can, every AI library is in Python. So it's a really simple way of turning an AI notebook into an AI web app. So that was something. Of course, you would need to run this on a platform that had GPUs and such, so it's much more resource intensive, but I thought that was an interesting, especially recently, that was an interesting, 4 years ago, no one was really doing that, but now they are.
Awesome. Last one for you. It looks like a lot of extra artifacts are created per request compared to what you would often see from IPyNB, or with the IPyNB file and all of that. Do you have any concerns about that at scale?
Like I said, you can't, at scale, I haven't really seen any problems. All these artifacts are being stored in, Azure Blob Storage or S3. So those are pretty cheap, and those are pretty. You can store a lot of data in those systems without any problem. The only thing is just keep in mind that running a notebook, there is some latency there. So as long as you're okay waiting, up to a minute for your notebook to execute, then you should be okay.
Awesome. Thank you so much, Koushik. Everyone.
Thank you.